It's one small step for man, one giant leap for mankind.
On July 20th, 1969, Neil Armstrong took us by the arms, looked us in the eyes and told us, "This isn't just me standing on the moon. It's everyone." We've dreamt of space travel since as far back as the Aztec Empire, but only at that moment did the dream come true. And from there, pop culture just exploded. Star Wars, Star Trek, Dune, Halo, Doctor Who. Our media has been held hostage by his assertion that the lunar landing wasn't just a privilege for a select few, but one giant leap for mankind. But it's half a century later, and 99.9999% of us haven't made it to space. Why? It's because it's expensive. Luckily, there is a way to make it cheaper, and it doesn't involve giant space elevators or electromagnetic moon cannons. Instead, the answer can be found by looking down to the soil and to the organisms beneath our feet, and their use in something called ISRU. Now, we know from published data that sending the Curiosity rover all the way from Earth to Mars in one go, that mission cost NASA about $2.5 billion. The rocket fuel needed for just the weight of the robot cost somewhere around $50 million. Now what if, instead of doing the whole trip in one go, we refueled at the International Space Station? Take it another step. What if we built the rover on the International Space Station and then picked it up mid-journey? That would save $50 million of fuel from the budget. Okay, but to build it, we'd need the metal. So where would we get that? Well, that's what ISRU is, in situ resource utilization. It means that we collect the metal from asteroids. Okay, but hang on. If it cost $50 million to send up a singular ton rover, how much would it cost to send a 550-ton excavator? The answer is a lot. Too much. Instead, what we could do is send up a handful of bacteria. Specifically, bacteria that could take on the same job as an entire industrial mining rig. And in 2019, the European Space Agency did exactly this. As an experiment, they sent up 3 types of biomining bacteria that can leach metal from asteroid rock, and they tested them in zero gravity on board the ISS. 2 of them struggled, but one of them, Sphingomonas desiccabilis, was unaffected and could leach metals without problem. Biomining could be what we need for outer space ISRU. And that's why we're proud to be offering up to $200,000 in crowdsourced funding for researchers working on biomining. It's just one small step to apply, but it's one giant leap toward getting research out the lab and into the field.